Welcome, everybody. Before we talk about the future, I would like to a little bit talk about the past. In the year 2000, I was and participated in a trade fair or a conference called Systems in Munich. And at that conference, there was a very famous, at least at that time, a very famous advertisement from Microsoft, which says, translated to English, an open operating system not only has advantages, playing with the diversity of Linux distributions that we had at that time, and fortunately have still today. Today morning, I ran in our booth into this here. Microsoft loves Linux. So thank you, Microsoft. We appreciate that. The real question, though, and this brings me to our presentation today, is what will happen in the next 16 years with respect to the operating system? Where will we go? And as a side question, where will Microsoft be with Linux love in 16 years? So let's talk about the future of the operating system and also a little bit of the operating system of the future. And I would like to start with a split brain situation that we have in our industry. So the brain, as you know, is separated in two parts, where some people say that the one is more emotional, the one more rational. And on the other hand, we also see that in the industry. And some people call that bimodal IT. Now, what does bimodal IT mean? It's essential that we go for 1 minute into this before we proceed. It means that we have traditional operations and also traditional applications which are constructed in a very programmatic way, where we have processes like ITIL around this, which structure everything, have processes for maintenance, for support, and so on. On the other hand, and this is what is called Mode 2 in this context, we have applications which have been designed in a much more shorter way, which have other processes like Scrum or so to produce them, and where also the approach to maintain applications is completely different. In addition to that, the applications themselves live differently. In the old times, so to say, or Mode 1, applications expected, for example, reliability on the infrastructure. Mode 2 applications do not expect reliability on the infrastructure, but they may expect reliability on their own, but not from the infrastructure. They are for throw away and restart. This brings new challenges, but also definitely also new opportunities. So these are the two sides of the brain of IT. And as an operating system vendor and an open source infrastructure vendor, SUSE certainly sees both sides of these IT infrastructure. So we have the reliability, we have waterfall models, we have conventional projects and long-term cycles. This is also an important thing, that we see long cycles of production, months or years. But in addition to that, we see something else. We also see that people request support for very long life cycles. So we're talking 10 plus 3 years, and if you then look in our books, we even have customers requesting 16 years support for one specific version. The other side is very agile. We're talking about keywords like DevOps. We have a lot of uncertainty, and new versions are spin-off in terms of days. If we take this serious, the thinking of a long-term support for something longer than a few months is an absurd thing. Nevertheless, to just mention this also here, SUSE already got several customers and partners requesting long-term support for one specific Docker version. That was, for me, something where I said, okay, something is not only bimodal here. So bimodal is, and I come back to this, not only bimodal in a minute. Mode 1 has things like classical operating systems. Now you may wonder why OpenStack is here on the Mode 1 side, where everybody thinks that cloud computing is a typical Mode 2 thing. The point is that OpenStack as an infrastructure from the thinking of how the infrastructure is constructed is a mode 1 thing, but it enables mode 2 things. On the other hand, software-defined everything, compute, storage, network, security, or whatever, clearly is something that is not thought in a mode 1 infrastructure, and we have things like Magnum, Kubernetes, and containers, which are enabling mode 2. So I already said it's not all black and white. And in my real opinion, we have a situation where we do not have one mode, and mode 1 and mode 2, but we have either what I would describe as a mixture of modes, long-term support for one specific Docker version, or we have, depending on how you live, what your use case is, and what your application is, several modes, not only 2 of those. I think this isn't too much simplification. Nevertheless, these 2 extremes are very good and important to keep in mind. Otherwise, you probably do not understand or do not agree to the challenges that I see for the operating system in the future. And also, you may not understand my challenges in describing how we consider the operating system to behave in the future. If you have questions, please just raise your hand. I will answer them in the middle of it. Okay, let's switch gears a little bit. Let's look at containers, platform as a service, and container as a service, and look at what operating system requirement I have for this kind of infrastructure. The operating system requirements for a container-focused world are that first, the operating system must be relatively small, where small always is relative. It must be self-contained, and it must be very easy to manage and upgrade. So everything what you have as a mobile phone, for example, in that way also people expect a container infrastructure to work. It's not that you should care about updates, but you expect stuff to automatically be upgraded. The next point is that in an infrastructure which has thousands of containers running, you do not want to care about the single container host to be installed. You really think of the whole infrastructure as one cluster. Now you could say, well, doesn't a cloud does that? Yes, it does. But it's not only one way of thinking such an infrastructure. And we see an overlap between a containerized infrastructure and the cloud, and also intermixes here. One very important and interesting aspect is called transactional updates. So this means that at one point in time, you can roll back with your update, but also there is an additional connotation. Rollback we already have today with SUSE Linux Enterprise Server 12, with Btrfs and Snapper, you have rollback. Transactional updates mean that it more is like a thinking of a database where you first put all your data into the database, and only at the point in time when you say close the transaction or perform the transaction, then the real implementation of this or the storage of this happens. Thinking for the operating system, this means a revert approach to applying updates. So let me just try to describe that in a different way. Today we do the following. We have a running operating system, we apply the updates, and if there is a kernel update, we reboot, right? This means that for a certain time frame, we have the old and the new stuff living together on disk. There have already been approaches in the past, SUSE Linux Enterprise Point of Service does that you have a second disk or a second partition where you first install your updates, then you reboot and switch to that partition. In the modern world, we could do that much easier in just one file system by reverting the way how snapshots work. So you have a running operating system, which can even be read-only. You create a read-write snapshot, you install into that, and if you are ready, then you close the transaction by rebooting into that new snapshot. So you don't need multiple partitions, you don't need a lot of infrastructure to be done, but you just execute a transaction like a database would do, and only when you really close it, it is active, not before. That's the real benefit of it. Now, there is also one more thing. The operating system that runs your container infrastructure should always be up to date. You don't want to bother with the idea of having a need to update this or that package. You don't want to bother if you have to change some configuration to make your update work. And you don't want automated control about, from the infrastructure level, if the update happened, if it was successful or not. So this means that combined with transactional updates, you want an always up-to-date operating system, which then helps you to not bother about the operating system update anymore. It's just there, and it provides you the respective extraction layer to run your containers on top of it. From that thinking, starting from that thinking, we are currently implementing what we call the SUSE Containers as a Services platform. And this SUSE Containers as a Services platform will have several benefits for you. So it will run anywhere where you can run a container, or today run SUSE Linux Enterprise. So it's meant to be physical. It is meant on physical hardware so that you can install it on-premise in your data center. It is meant to be available for the installation in existing private clouds, like, for example, SUSE OpenStack Cloud. And it also will be available in public clouds where we already are. So Amazon, Google, and Microsoft Azure is just the most well-known public cloud environments. By deploying such a system anywhere, you have the flexibility also to switch between those depending on your needs. So you get a lot of flexibility, and also people who are developing your applications for you or for a broader audience, those are able to apply a DevOps approach by very quickly deploy containers. There is one thing though. Now you might think, we might already have this today. The real benefit of what we are planning and implementing today is that we are combining these ideas of a container platform with the existing code base of SUSE Linux Enterprise. So you get an enterprise-grade operating system with all the security certifications applying, with the full maintenance and support infrastructure in place at SUSE that you also have for a classical or traditional operating system. This is what we SUSE internally call common code base. So we have one pool of packages where everything is built upon, regardless of the target, like cloud or physical or virtual, regardless of the flavor, desktop, server, container as a service platform, or the architecture from A to Z, where now we announced that we have from ARM to Z really not all the characters, but at least the complete alphabet. Okay, all the characters would be challenging. By having such an infrastructure, it will help accelerate the business innovation for you, because you can work with people who just want to deploy a container anywhere and just have such a container available. SUSE Linux Enterprise MicroOS is the underlying operating system. That's how we call the operating system part of what I just described. And it's a modern operating system which is designed for container deployments. And this is important, it is never meant to be installed as a single server. But the whole infrastructure that we will provide is optimized for large deployments, where large might be 5 or 10. I think the fun starts at about 20, where you really then see a scalable infrastructure. MicroOS inherits the SUSE Linux Enterprise knowledge, so all the knowledge of building packages, of having a secure maintenance model, and it redefines the operating system, though, into a reliable, easy to handle, and from that perspective, small platform. Now, I already described what a transactional update is. Some people also call it an atomic update. It's obvious that we have avoided that topic because it's a little bit loaded with another implementation. One other thing that we think about is to, by default, enable automatic updates. Who hates this? Okay, thank you. But because there are several people who do not really like this, there certainly will be a way to also disable this on the request of the administrator. On the other hand, we have learned that many people will like this because they just do not want to bother. It will also be possible to define maintenance update windows so that you have an easy way to combine your potential hesitation with a reasonable effort. So by saying that you only once a month allow an automatic update, and if you want something in between, you do it manually. That's also an option for you. And as I said before, the operating system itself will be defined to scale out, so it will not be a single machine that you usually want to install, but a bunch of systems in a cluster. Looking at the right side of the slide, you see something that you did not expect, at least if you know other operating systems targeted for container infrastructures, and this is the word RPM. Now, you may wonder, why is SUSE so old-fashioned and still sticks to RPMs? That was a question that I really got yesterday talking to an analyst. He said, you described that in a so old way. What's the point? The point is that we looked at what the market need is, and that we also looked at what people are doing with existing container infrastructure platforms and what functionalities they are starting to implement just now if they have such a platform. And the fact is that we see that people are starting to re-implement functionality that we already had with just installing packages on an operating system. So meaning to implement a way to have fine granular changes in a pragmatic and programmatic way to be applied to the operating system, that they are starting to implement this on architectures and platforms which before were meant to be, oh, we just throw an image there and everything will be fine. Reality is that just throwing an image there has a specific risk and takes away flexibility that you, for example, might want in such an infrastructure. By keeping RPMs and combining transactional updates with the ability, not the need, just the ability to continue to apply RPMs to the infrastructure, we do not keep away this flexibility, but by implementing transactional updates, we deliver the same ease of use for the operating system platform. That's the idea. I already said that it is possible to implement the transactional updates using snapshots, for example, as we have today. And for that reason, the plan is to implement the transactional updates using the snapper and snapshot technology that we have today based on Btrfs on the file system level, so that we do not need an additional overhead and an additional layer which does this for us, but the existing infrastructure does it for us just with this revert approach to snapshots. So not do a snapshot, install, do a snapshot, and then you are in the system, but do a new snapshot, install into the new snapshot, close the snapshot, reboot, and then you are in the running system. So that's the basic change to today, where nevertheless this remains the same infrastructure. Yes?
Just to clarify, are you applying the RPM inside the container?
No. So we are talking about the host here. So we are talking about the host. Applying RPMs in a container is something that is even possible, but this is not what I'm talking about. I'm talking about the platform, right? So a good question. Thanks for the clarification. We are talking about the host platform for running containers on top. Inside the container, you are free what you want to do. You can, by the way, use containers with RPMs inside. Most people, though, do not do it. Is there another question? No? Good. Okay, so it's a platform. We also will combine will ship this infrastructure with a plugin to the existing Salt technology that we are using in SUSE Manager. If you are not familiar with that, you're invited to join the SUSE Manager sessions, certainly. Salt is a management infrastructure. It's an open source project as well, and we are leveraging that throughout our code base and throughout our products. So the idea here is that for managing such an operating system in a scalable way, you also need a scalable infrastructure for managing details, configurations, and so on. And this is what we will use Salt for. We also plan to leverage the existing Cloud Init tool. Who does know about Cloud Init? Anybody heard about that? Okay, a few people. Robert, you also should have raised your hand. And Cloud Init actually is a way to tell a system a set of configuration options, including the authentication way, and some keys, for example, directly at first boot up. And if you use that, you have a very elegant way to include a system into a cluster without the need to configure every system independently. But this really scales, and it is used usually in OpenStack environments. We plan, and I think we have a prototype already, to really use that also for the physical deployments, because it's a very nice way if you have a physical system and you have an installer which brings the stuff to the physical hardware, that you nevertheless want to give this a real set of things which are unique to that machine, and the rest you can apply as usual. The focus, as said, is on scalability, and what I just said about Cloud Init and Salt clearly goes in the direction of usability and a pre-configuration which makes the deployment as a cluster as easy as possible. Questions so far? Good. That was the operating system layer. Now, on top of the operating system layers, there will be a container engine. At this point in time, we're talking about Docker, what you already have today in SUSE Linux Enterprise Server. So that's part of the OS level for me. But on top of this, you need something to not only manage this cluster, but you also need something which orchestrates the containers that you put on your cluster. So orchestration has several aspects. It has the aspect of deploying containers, applications. But the trick is, if you're in a container infrastructure, you are not only talking about one container for one application. Very often, you are talking about a set of containers, like a multi-tiered infrastructure, a set of containers which wants to be considered one application stack and wants to be deployed as one application stack. This means you need an infrastructure which handles your load balancing, which handles your container internal networks or inter-container networks, and which handles also the scalability of the several layers of your multi-tiered architecture for you and measures and scales appropriately. So imagine this. You have a database server, which is only one server. Is there any question? Okay. So imagine this. You have a multi-tiered architecture. You have a database layer. You have an application server layer, and you have a communication layer or a web server or whatever. So if you see that there are thousands of questions of requests from the network are coming in, the infrastructure should decide for you that you want to scale out the upper layer level, which goes out to the network and to the clients directly. And then, as a next run, you might see that also in the application layer, you need more power. Then this is also scaled up, but it might be that you don't, because you just have empty requests from a botnet or whatever, which do not go deeper into your architecture. But you want to be able to scale this automatically. And this is the rules that you give such an orchestration engine, such as Kubernetes, which helps you to deploy complete stacks and which helps you to manage the boundaries and also the performance capabilities of your application stack. You could also see that from a different angle. You could also see that you are better prepared to use the capabilities of your existing hardware with such an application layer and such an orchestration layer, because it will help you to utilize your hardware as much as possible. Now you may wonder, I've heard that, right? 10 years ago I heard that in the virtualization area. So what's the difference? From my perspective, there are two differences. The virtualization layer added another layer of complexity by stacking complete operating systems. What we do with containers is reducing these encapsulation of things that you want to manage and that you want to orchestrate and assign resources to. You're bringing it back to a confined set of applications or programs. So basically, it's a reduction of the virtualization idea, but by reducing it, you also get more performance out of it, and you get more flexibility because you have every single tier in a separate container, and then you can scale it this way. And Linux provides the capabilities already for, I think, 6-7 years to have containers. Some of you may have used typical Linux containers with /11 SP2 already in the past. With this way of managing containers using such an orchestration layer included in the infrastructure, we are confident that this will help people to get applications more quickly deployed. And now coming to the right part and to the title, Kubernetes is such an orchestration layer. It has been invented and programmed by Google mainly. We have done an analysis on the orchestration options that we have. There are several outside, and have decided that we focus on Kubernetes as the orchestration layer, which is the most well-known, even if it's slightly complex, but the most well-known, the most scalable. And also, and this is one of the things that is nice for us, I talked about Salt before. There are ways to integrate Salt with Kubernetes in both ways. So Salt configuring Kubernetes, or also Kubernetes helping with the Salt deployment. So this is another option. Are there questions to this? If not, if you are interested in participating in the early development and get updates on what we are doing, when we are doing it, there is a very new mailing list, CASP, Container as a Service Platform at listsuse.com, that is active starting today. And you can just subscribe to this mailing list at, I think it's listsuse.com. I should have the web link there as well. But you will find it if you, for example, are a beta customer, so you will find this mailing list. Okay. There's one thing where many people are confused, and this is, doesn't SUSE have this already? You have JUICE already. What's the difference between JUICE and this MicroOS that you were just talking about? So let's first start with a small verbal or words thing. A MicroOS is not about being micro, nano, pico, or whatever. It is about a microservice OS. This means that the operating system itself is not necessarily small, because if we are talking about a full-blown operating system with a complete container stack like Docker plus an orchestration platform running Kubernetes with a lot of Kubernetes modules which help you with plugging into networking, plugging into storage, plugging into security things, or scheduling options, you have an operating system which is not small. But you have an operating system which helps you running microservices in a much more abstract way than a typical SLAS system is today. On the other hand, you have JUICE, which is a general purpose operating system as it is today, just a little bit squeezed and made smaller to be more comfortable and quicker to run up. But still, and this is important, JUICE is a general purpose operating system just in a small way, while MicroOS, underneath of the Container as a Service platform, is a single-purpose operating system to run containers and microservices. Yeah? Multi-purpose, single-purpose. The second difference is that JUICE can be easily extended to be a full SLAS. You register it with the SUSE Customer Center or a local SMT server, and you get a full SLAS. You get all the modules, you get all the installation options, you get everything. While MicroOS, as I said, is a single-purpose thing, you will not get all the options because you don't need them. You only want to do one thing with this, run a container infrastructure. This also means that for JUICE, the availability of all extensions is given, like high availability or real-time, while for a MicroOS, we do not expect people to expect high availability and not expect real-time. Wait, I said something dangerous for data center people. I said that there will be no high availability in MicroOS. This is true and this is wrong. The fact is that with the Kubernetes infrastructure that I just described before, you will not get high availability on the OS level, but you get high availability on the services level. The Kubernetes infrastructure takes care that you have the ability to always run at least one instance of your service that you want to run. So it looks on the service level for the availability. It doesn't look on the underlying infrastructure layer. This is a different approach, and this is, by the way, also one of the differences between mode 1 and mode 2, which I started the presentation with. So here we have a real difference between the two modes, which we see also in the availability of the software. You do not need a high availability extension as it is today if you want to run a Kubernetes orchestrated microservice cluster of systems. Nevertheless, you can provide availability to your service. That is the important thing. In JUICE, you have full control over the installed operating system. In a MicroOS way, you get transactional updates which keep your system secure, stable, and up to date, but you have a single-purpose OS. You also have in JUICE full control over the installed packages, updates, and upgrades on the other hand. MicroOS, as said, transactional updates, and it is made for cloud, Kubernetes, and potentially in the future platform as a service on top of this. You have in JUICE the full set of deployment and management options, and in MicroOS, because it is a cluster that you want to approach as one living thing, you have a reduced end-user interaction, and it is focused on large deployments, so you have one access point to your whole cluster, and basically you do not care if system number 7 or 17 fail, as long as your service runs on system number 8. Oh, you probably do not even know where it runs. You could know. Summarizing, SUSE Container as a Service platform. Okay, SUSE Container as a Service platform is a product that we're currently developing on top of SUSE Linux Enterprise 12 SP2. And we are inviting you to participate in that approach, to learn about it, and then when it will be available, also participate in the beta program going on. Okay, so that was this. But there's more, right? There's more OS, or isn't it? So is this everything we need in the future? Probably not, probably. So we have described the needs of a container-focused world. But the one thing we completely ignored is that there are millions, if not billions, I don't know, millions of systems out there which run a classical operating system, and where the applications that you run on your classical operating system do not expect that they are migrated to another system quite easily, but they, for example, might expect that you have persistent storage, that you have high availability in place for the application itself, because it really expects this to have it, because it's so mission critical to have it. So you also probably do not want to be limited in the way how you install your operating system, or you are someone who builds embedded systems and you say, well, just having this single purpose operating system is not good enough for me. I need more flexibility. So this is where the requirements of the classical OS that we're serving and providing today come in. It covers multiple use cases, it covers multiple installation ways, and it also solves multiple problems in different use cases and in different ways. So everybody may have a different installation, every may have different requirements to the life cycle. One thing that, for example, also several of our customers expect is the major version upgrade. So you have a running operating system, and do you want to bring that to the next level? You want to bring this to the next generation of operating system. In a MicroOS container as a service platform world, you would just throw away the host, install a new host, and every new deployment and new development is on your application level. But probably you have, and most of you have, an infrastructure which is built on a classical operating system approach, where you have the OS installed, it is configured and optimized for the application that you run, and you want to keep that optimization, you want to keep that knowledge in your data center. So this is where a classical operating system comes in, and it is always on. So I say it is a classical, where classical really means in the good way of the word, like classic music, not in the way of legacy, which is a word I really hate because it is kind of pejorative. I think that's the right English word for this. In the end, this means that as questions? Okay. In the end, this means that as SUSE, we better should not limit ourselves by only running into the everything is a MicroOS with a container as a service platform world, but we should consider that we have a very loyal customer base out there with rightful requirements onto a operating system which is a typical classical operating system. And this is a challenge. And this is what I said in the beginning, right? There was this brain, you remember this. So as SUSE, we have to have one side of the brain, probably the emotional, on the classical OS, and we have the other side of the brain, probably the rational, I don't know, on the side where we say, oh, these MicroOS thing, containers, this is really something which helps people in the future to deploy much quicker, to be much faster and much more efficient. On the other side, people are already efficient, so this is where we struggle a bit on the other one hand, but also have solutions. And one of these solutions I would like to show, and this is what we are currently thinking for the next generation of SUSE Linux Enterprise. Before I start, one important thing here. On the very left side, you see one word, or three words. It's called Common Codebase. Does anybody know what this is? Yeah? Patrick?
So we build everything from a common stream of packages that we get from the open source community, and we build it with tooling that's specific to the platform that we're targeting.
Yep, good, thank you. Very good. This is important because this enables a lot of things, and we might see that it helps us also in the question that we have. First, let's look at the past. In SUSE Linux Enterprise 8, 9, and 10, SUSE shipped a monolithic operating system. It was just SLAS, and everything was on SLAS. You had SUSE Linux Enterprise Server, high availability was in there. In SLAS 10, I think SP1, I'm not sure. No, SLAS 10 GA, we added Xen virtualization, so the first open source hypervisor was on there. Everything was packaged into SLAS, and that was great. It took a lot away a lot of flexibility. Because we saw that we need more flexibility, in SUSE Linux Enterprise 11, and more so in 12, we introduced a modular approach. So we have SUSE Linux Enterprise Server including virtualization. We have extensions like high availability, live patching, real-time, and workstation extension, which people can add but do not have to. And we have modules which are an inherent part of your SUSE Linux Enterprise server subscription, like weapon scripting, toolchain, and containers. And talking about containers, yes, this is where Docker lives, right? In the containers module, we have Docker. Here in the server itself, we have LXC, libvirt LXC, so the Linux containers part. It's a virtualization. And we have in SUSE Linux Enterprise 11 and until SP2 and 12, starting with SP1, we have juice. But as I said before, and you see that in these arrows, our juice in 12 is something a little bit an outlier. It is a squeezed SLES. So we took SLES, we found it's too big, and then we started to squeeze it. We took away documentation, we took away this year, we designed a special kernel package, which is on juice usually, which is about 100 megabytes smaller than the standard kernel, because this kernel package has no hardware drivers. It's only all virtual. It runs in public clouds and virtual environments, but not physical. And so we made it small. Yeah, we really made it small, but it's a little bit artificial. And we add, as I just discussed, we add a MicroOS, which then drives the Container as a Services platform starting with next year. So what is the future? I already asked that. So the future could be that we do all Container as a Services platform. But as I have seen in the room here, not everybody would agree that we run everything containers starting in 18 months from now. Or should we? On the other hand, we could look at starting with juice. So everything starts with a very small operating system, and I say it's a designed juice, so we design the whole common code base, look there, the whole common code base to be small and be able to create small images, and then we put all this around, and we could even put a server extension around or the sub-integration as a separate thing so that you are more flexible in combining things. That's a valid idea. And, well, yeah, we could do it. But the question is, if you do that, then probably you would have still a classical OS, but you would not save or serve the container or cluster way very nicely and efficiently. So coming back to the common code base, that's an important point. For the future, we plan what I personally call a molecular approach. So you first have as a starting point really this designed juice. So the common code base over the next 2 years will see, and you will see that if you follow OpenSUSE also there, will see some improvements and packaging things more efficiently, reducing dependencies or splitting packages so that you have a more ability to package more efficient and smaller. And then we can go out and design things around that, starting from what we have done today. So there is not much difference with respect to what you get in the end, but internally it helps us to design things more efficiently. For example, what you see here, right? Juice plus high availability plus the server extension plus SAP integration. This is what we call SUSE Linux Enterprise for SAP applications today. And most probably you will not see that as 4 bubbles, but this is just the internal representation, how SUSE makes things more easy and more flexible working together, but you still get your SUSE Linux Enterprise server for SAP applications. This whole approach also solves one problem that I, as a product manager for security, struggled a bit around, and that was how can I provide people with a security certified desktop? That's one of the reasons why we have this workstation extension here. But having a workstation extension on top of SLES plus a SUSE Linux Enterprise desktop is a little bit awkward, and many people do not understand this rightfully. So what this means here, a juice plus a workstation extension and a toolchain module basically could be what you know as SUSE Linux Enterprise desktop today. But because the juice covers all these certified parts, you get a certified desktop. because we just have this internal module and we can describe to authorities to do certifications that this is something that is certified as its own, right? But then, where are my containers? Where is my container infrastructure? Yeah, I could say, okay, I take the containers module, I put it on here, and then I build my infrastructure. But this would not give this scalability that I talked before. The Kubernetes integration would be missing. The automatism would be missing. So what we think about is to introduce a twin to JUICE. So the MicroOS in the next generation basically is something like the JUICE, just with all these capabilities that I described before. Transactional update would only be in the MicroOS. The automatism to scale it out into a cluster, that would be the MicroOS, while the JUICE is more traditional operating system. The JUICE would have the ability to migrate from 12 to 13, but the MicroOS would something that you just deploy and throw on your system or into your cloud. And on top of this, we then can build a container as a service platform which not only serves for one application that you built, but also may serve in the future, and we are in internal discussion about this, may serve, for example, a SUSE storage or cloud product, or your storage, whatever you think, and help people to deploy software quicker and more efficiently. And to show that this is also possible for customers, because we have the tooling available, certainly out of this pool of packages that we provide, you also could build your own containers and put them as a container as a services platform. And last but not least, it is an option that we extend the use for MicroOS, as I said, transactional update made for clusters, also into future use cases which go beyond just containers. So now you may wonder, when do I get what? So SUSE Linux Enterprise 13, which will follow most probably this approach that I just described, is targeted for, let's say, mid-2018 with a little bit of variance, but not too much. And you see that we built really a structure here. We have /11 still being supported. We have /12 with yearly service packs made around this. And we have SUSE Enterprise 13 in the middle of between SP3 and SP4, so some kind of mid-next year, mid-2018, not next year. And one thing is missing, right? So the container as a service platform that I just described in half an hour, this is targeted to be next year, right? So a year before 13, we are planning to have a container as a services platform available on the basis of SUSE Linux Enterprise 12. This is not yet a fully committed capability, but we are confident, and this is why we allow ourselves to present and to provide the email address that you can directly subscribe to, and also to ask for your feedback on this whole question of how the operating system of the future should be designed, and it helps to shape your future for yourself. With that, thank you very much. Do you have questions? Then feel free. Yeah?
You talked about using ButterFS and snapshots to transactional updates. What happens if the transaction fails?
Okay, so the question is that I talked about ButterFS transactions and updates. What happens if the transaction fails? I also talked about Kubernetes as an orchestration layer. So the idea is, and this is really what Kubernetes provides, is that the Kubernetes infrastructure controls this action. So if the transaction fails, it will be rolled. It can be rolled back, and Kubernetes can do it when it sees that the update did not perform. So the idea is to have a real automation combined of the orchestration layer together with the automatisms of the operating system, and then the orchestration layer helps the operating system to come into a reasonable state again. kind of what you are able to do with SUSE Manager today, with the exception that SUSE Manager is more a manual thing where you can click on rollback, while on the Kubernetes kind of orchestration, the orchestration layer says, oh, the update failed, or the machine doesn't live anymore, so I go to my whatever IPMI, reboot the machine in the old snapshot, and it goes on. Does it answer?
Well, the bit IPMI reboot machine into old snapshot, don't understand how that pattern currently works.
Yeah. So how it currently works is that you would have to have manual interaction, but this can be done also automatically.
By choosing a ButterFS
Snapshot by
via IPMI.
yeah, no, well, by jumping into the bootloader, yeah.
You envision a future where, just as today, there are cloud service providers, there'll be container service providers where people just deploy containers?
So the question is if I expect a future where, just as we have today cloud service providers, there will be container service providers. Let me answer so I don't have a crystal ball, but let me answer this way. I assume that cloud service providers will add, and they are already doing this today, add the capability of running containers also there. So this will intermix, or it will develop into each other, and depending on what people want to do, they can either deploy containers, or they can deploy operating systems, or as in our case, they can deploy their own container infrastructure on a public cloud, for example. That's also an option, right? So there is no either or, but there is a intermix and a fluent path from one to the other. Other questions? If not, then thank you and enjoy.